Hello, Honors Algebra 2. In this video, we're going to do one example of an application of arc length and applied to a rolling wheel. Okay, and we have to develop a couple formulas. So suppose you have a wheel, circle, that's rolling. Okay, now first thing is don't worry about the wheel rolling for a second. Let's just think about the wheel rotating. If you are if I were to paint a paint dot on the right-hand side of that circle, and I let the wheel rotate a little bit, then the wheel, let's say it rotates this direction, the wheel will rotate, and that point will travel to a new spot on the wheel. Now, we can use the arc length formulas that we just developed in the prior video, where this is r, and this is theta in radians, and the arc length is theta r. So if I know the wheel turns 2 radians, then I know how far that paint dot on the wheel has traveled around the wheel. Okay, so I've got this formula, S equals theta r. Now, we know that velocity, the speed, if it's not direction, it doesn't have a direction, but we know that the velocity of that paint dot that's on the circle is distance per time. But distance is now arc length, because distance is the arc length around the circle. So the velocity of that paint dot that's on the edge of the circle is the arc length per unit time. And but there's a new concept, and that is angular speed. And angular speed is often written with the letter omega. Omega is a Greek letter that just looks like a W. It's got a little bit more curve to it usually, but it's a standard notation for angular speed. And angular speed is the rate at which the wheel is turning. And if a wheel is turning faster, then that means it's spinning through more radians per unit time. If it's rotating very slowly, it's rotating less units per unit time. So angular speed is the angle per unit time, whatever that may be in your problem, whatever the unit is. So these are all equations to know, but what it allows us to do is it actually allows us to derive a formula for the velocity of the particle going around the circle, but in terms of the radius and the angular speed. So let me derive that for you. So we know that the velocity is s over t, which we have above, but we know that s is theta r. But I can rework this to be theta times r over t, but r over t, actually, that's not the way I want to rewrite it. I just realized I actually want to put the r out front and make this theta over t. Now, why did I want to do that? I want to do that because theta over t is our angular speed. So this is r times omega. So what we get is a new fourth equation, which is the velocity of the paint particle traveling around the circle is equal to r omega. This is velocity of the particle moving around, or the paint spot moving around the circle. This is the radius of the circle, and this is the angular speed that the circle is turning. So if the circle turns faster, the paint dot on the edge of the wheel moves quicker in velocity around the circumference of the circle. Okay, so in this problem it says your heavy-duty truck has wheels 48 inches in diameter. If the wheels are rotating at 630 revolutions per minute, find the truck's speed in radians per second and in miles per hour. Okay, so some conversions. 1 revolution is 2 pi radians. 1 radian is 1. So 1 radian is 1 radius So let me say that again. 1 radian is equal to the length of 1 radius. So if the radius changes, so in this case the diameter is 48, so the radius is 12. Okay, let's work through this now. So we are given that it's rotating at 630 revolutions per minute. So our one way of writing our angular speed is we can start by thinking, well, we were given 630 revolutions per minute. Well, if I want to convert it to angular speed, I need to convert it to angle per minute, because angular speed is angle per minute, but this is revolutions per minute. So I just need to convert. So I'm going to multiply this by, I'll multiply this by 2 pi radians per revolution. So 2 pi radians per 1 revolution. The revolutions cancel, and I get, so if you multiply this out and work it out, it's 1260 pi radians per minute. So that is our angular speed. So we have that omega is 1260 pi radians per minute. And the question said, find the truck's speed in radians per second. So I just need to convert minutes to seconds. So I'll just multiply this by 1 minute per 60 seconds. And little unit conversion, I get the I get the minutes to cancel. And I did this calculation ahead of time. 21 pi radians per second. Okay, so if you reduce that, you're going to get 21 pi radians per second. Okay, so we have found our, so we found the truck's speed in radius per second. That's angular speed. And we also want to find the speed of the truck in miles per hour. Now, if we have a circle, a wheel that's rotating like this, then the speed of the truck is equivalent to how fast a point on the wheel is going around the circle. Now, why is that? There's always one spot that is contacting the ground. So the faster the wheel turns, the faster this point that's contacting the ground will move around the circle. As the wheel rolls this direction, the point contacting the circle will move this direction. So when this wheel moves a little bit this way, this point will eventually be on the ground, and all the points on the circle will eventually touch the ground. So the speed, the velocity that this point is moving around the circle is equivalent to the velocity of the truck itself. So, but we have our formula. We have our formula, which is that the velocity is r omega. So we have velocity is r omega but the velocity is, let's see, they gave us that it's 24 inches for the radius and 21 pi radians per second. And that turns out to be 504 pi inches per second. Now, remember in my prior video, angles and radians and degrees, those are dimensionless. So our unit of this velocity is inches per second, which is what we expect, a distance per time for velocity. That's inches per second, but we want miles per hour. So now it's just a bit of work to convert this. So we would multiply 504 pi inches per second. We need to convert inches to feet. So we would multiply it by 1 foot per 12 inches. And we would convert feet to miles. So it is 1 mile per 5,280 feet. And that's the conversion from feet to miles. And then we want it in miles per hour, but we've got our time currently in seconds. So we need 60 seconds per 1 minute. Let me just keep track of this. So inches cancel with inches, feet cancel with feet, seconds cancel with seconds. So now we have miles per minute, but we want miles per hour. So we need to convert 60 minutes for 1 hour. And then the minutes will cancel and we will be left with miles per hour. I did the calculation ahead of time to avoid doing that on the video and make it a little quicker. You're going to get 89.96 miles per hour when you multiply out all this. You just do 504 pi times 60 times 60, and then divide that by the quantity of 12 times 5,280. And this is what it works out to be. Okay, that's the one example. That's enough for you to be able to try your homework on this. And again, not on the MCA, but we may have a question on this on the test.